So in this video we're going to talk about the opposite of synthesis, decomposition. Now synthesis means to put together. I forgot to mention that on that particular video, but it's not a big deal. You can still figure what how to do a synthesis reaction without really knowing what it means. Well, decomposition means the opposite of put together. It means to break down. So, how do I know I have a decomposition reaction? Well, you're usually starting with a compound. And an ionic compound to be more specific. So, and ionic compounds, they'll end in IDE or ATE. We won't see this, but they also end in ITE. All right. So, don't worry about that one. But if you see it ending in IDE or ATE, then it is a decomposition reaction. And you will find no plus sign in between the A and B. Okay. So what it breaks down into is A, because A always has to be the metal, and B always has to be the nonmetal. So you will get the elements. Okay, now we went over in synthesis reaction, how to figure out if it's diatomic, monatomic, stuff like that, or tetratomic. So, and we'll talk about the oxidation numbers. This will always be a solid, and depending upon what the elements are, they could be either solid, liquid, or gas. Okay, so let's talk about doing one of these reactions. So let's say we start with calcium phosphide. Okay, again, ending in IDE. No plus sign in between the calcium and the phosphide. That is telling me it's decomposition. So, since it's ionic, we follow the ionic rules and write it out like this. Checking the charges and then crisscrossing them. Alright, did I do that right? No. Again, I see a lot of this where people don't crisscross. So, Ca2 plus, P3 minus, I write them together. That's how it's got to go. And like I said before, this will always be a solid. Well, it's going to break down into the elements that make it up. Calcium and phosphorus. So, are any of these diatomic? Well, calcium is not. Phosphorus is not diatomic, but it is tetraatomic. Okay? And we got to put a 2 in front of here and a 6 in front of calcium to balance that out. And again, calcium will be a solid and a solid, and you could look up what these things are. Okay, there's not too many gases on the periodic table. Okay, everything else is a solid. So things that are gases, again, nitrogen's a gas. It's diatomic. Oxygen's a gas. Fluorine's a gas. Okay, again, it's diatomic. Chlorine's a gas. Okay, bromine is a liquid. And iodine, well, that's a solid. The only other gas you have to worry about is hydrogen. That is a gas. Now, obviously, the noble gases are gases, but they tend not to form compounds at all, so we don't have to worry about that. So let's take a minute and let's have you try one. Iron 3 oxide. Hit pause and tell me what it's going to make. And then after that we'll talk about the oxidation numbers. Well, welcome back. Okay, so hopefully you understand that this means that iron has a 3+ charge. Our good old friend oxygen has a 2- charge. So Fe2O3, again, not making the same mistake, crisscrossing the charges. That starts out as a solid, so it's going to break down into the elements that make it up. Well, is iron diatomic? No, it's monoatomic. How about oxygen? Yeah, that's diatomic. Okay, so oxygen again is a gas. We just talked about that. Iron's a solid. So we need to put a 3 here to balance the oxygens and a 2 there. That gives me 4 irons. Now, if you talk about the oxidation numbers. Okay, well, again, any element, the oxidation numbers are 0. Okay, for a monoatomic ion, the oxidation number is going to equal its charge. So iron's oxidation number is +3. Oxygen is 2-. So iron is going from a +3 to a 0. Oxygen is going from a -2 to a 0. So remember, oxidation is loss of electrons. Reduction is gain. All right. So again, if you need to go see the oxidation video, go click on that now, or we talk more about that in synthesis or the video. So this is gaining electrons because electrons are these negative things. So if you are positive and you gain negative charge, you become less negative or closer to 0. So that is my reduction. Oxygen is going from a -2 to a 0, so it's losing, and that is my oxidation. So that is the basic type of decomposition reaction. Now, there are 2 other ones that you need to know for both honors and CP. Well, CP just needs to know the decomposition of a chromate, not a chromate, a carbonate. Okay? So, let's say I have lithium carbonate. Alright, we're showing here. So we have lithium carbonate. So, again, there's nothing else. It ends in ATE. There's no plus sign between them. So that's telling me it's a decomposition. So it's ionic. So lithium has a +1 charge. Carbonate is a polyatomic ion that has a -2 charge, sorry. So, again, crisscrossing the charges, I get Li2CO3. So, when you have a decomposition of a carbonate, okay, you are going to get CO2 gas all the time, and what we call in the business a metal oxide. Okay, that's whatever metal that you have that is decomposing and oxygen. So what does that look like? So I'm finished going over my reaction here. So carbon dioxide as a gas, this will always be a solid. So my metal oxide, well, my metal is lithium, so lithium plus, and oxide is 2-, so Li2O, and this will be a solid. Okay, and this one just happens to balance out already. You get 2 lithiums, 1 carbon, 3 oxygens, 2 + 1 is 3, and you're good to go. This is a non-redox reaction. Okay, so you don't have to worry about that, the redox part. So I'll give you an example, and let's see if you can do this. So let's do something a little more challenging. Let's do something like, I don't know, to do iron 3 carbonate. So again, there's just one compound listed there, so it is a decomposition. Now again, carbonates decompose in a special way, as you see up here. You get CO2 and a non-metal oxide. So hit pause and try to predict this reaction, and we'll give you the answer when you get back. Welcome back. So again, we need to write out the formula for iron 3 carbonate. So Fe2 parentheses CO3, again starting it as a solid. It's going to break down into carbon dioxide gas all the time. Okay, that never changes. And then again, the metal oxide. Well, what's the metal oxide? Well, the metal is iron 3 plus. The charge never changes. Oxide is 2 minus. So what would the formula then be? Fe2O3, solid. Okay, now this one, again, is a non-redox, so you don't have to worry about redox. And we have to go and balance the thing. We have 2 irons here and 2 here, but we have 3 carbons and 9 oxygens. So if I put a 3 here, that gives me 3 carbons. We have 3 times 2 is 6, plus 3, and that's 9, and you're good to go. Okay? So that's how you do a carbonate. And that pretty much ends it for CP. Now, if you're in honors, you have a bonus one to do. So if you're in honors, you have to do the decomposition of a metal chlorate. Okay, and what a metal chlorate is going to give you all the time is, again, this is just for honors, it's going to give you oxygen as a diatomic gas and a metal chloride. So let's talk about one example. So let's use something like calcium chlorate. So calcium has a +2 charge. Chlorate is a -1 charge. So we write the formula Ca parentheses ClO3 2. And again, like all the other decompositions, it'll always be a solid. We are going to get oxygen gas as a diatomic gas, and then a metal chloride. Well, the metal is calcium, and chloride, when it gets a charge, is -1. Again, putting a little plus between them, we get CaCl2. Okay, and that will always be a solid as well. Anyway, so we got to go and balance this, I think, because the oxygens are not in balance. You have 6 here, so you need to put a 3 there, and that basically takes care of the balancing part. Now, this is a redox reaction. As you can see, the calciums are not changing, so the metal is not a part of the redox. What's a part of the redox is the chlorate, okay? Because over here you have chlorine at a +5. Okay, so again, this has to equal -1. Oxygen is -2 times 3 is a -6, and that chloride is, we call that X, so it has to be, that turns out to be a +5. All right, again, the oxygen, so the chlorine is a +5 here. The oxygen is a -2, because oxygen in a compound always has a oxidation number of -2, unless it's a peroxide, but we're not going to do anything with peroxides. That'd be a -1. Over here, on the product side, well, oxygen is a 0. This is an element by itself. And chlorine is a monoatomic ion. So that means its oxidation number equals its charge. All right, so the oxidation number is -1. So let's kind of get this together here. So chlorine goes from a +5 to a -1. Oxygen goes from a -2 to a 0. So chlorine is gaining electrons, so therefore it is being reduced. Okay, and oxygen, okay, is going from a -2 to a 0, and it's being oxidized. Okay. And that is decomposition. Okay. If you like, we can give you a little practice we want to do. Do a tough one. Maybe a tough one might make it too hard. So let's do sodium chlorate. Okay, well, what does it give us? So hit pause and then we'll give you the answer. Welcome back. So sodium chlorate is Na2, so not Na2, but I was thinking it was something else. So again, sodium has a +1 charge, chlorate -1, so it's NaClO3. So we're going to get oxygen as a diatomic gas. That'll be your solid. And get the metal chloride will be sodium chloride. Again, sodium having a +1 charge and chloride having a -1 charge. And again, this will be your solid. Put a 3 here to balance that oxygen and a 2 there, so it gives you 6. And you got to put a 2 there. Okay. Again, the chlorine goes from a +5 to a -1. The oxygen goes from a -2 to a 0. So again, this is your reduction, and this is your oxidation. Okay? And that is decomposition.